So we're asked to use this graph to write a possible equation in y equals ab to the x form. So this certainly looks like an exponential curve, and we're going to make our data fit that. If you take a look at some of the things that we can see from this, it appears that they're telling us what the zeroth term is, and they're communicating that information right here by recording at 0. The curve is at a half, right? It's at 0.5. So if I'm fitting things in this form, y equals a b to the x power, the first thing I notice is that a would have to be the number 1/2, right? It's 0.5. So I know my initial value is 1/2. The other thing that I see is by the time I multiply by some value b 1, 2, 3 times, I have a jump of 499.5. In other words, I'm sitting at the number 500. So at 3, I'm at 500. Now, if I think about that, and it's kind of deceptive how they wrote this, but they're saying that we're having an increase of 499.5. An increase from what? Well, we started at 0.5 and we're jumping to 499.5. So this point that they're indicating is the point x is 3 and y is 500. So if I consider that point and this initial value together, I get the following expression. Y is 500 at that point, and I'm going to write that equals 1/2 times some value of b I do not know yet, raised to the x power would have to be 3 in this case, right? Because x is 3, so raised to the 3rd power. So if I want to solve for b, what I'm going to do is I'm going to take 500 and I'm going to divide both sides of that equation by 1/2. So I'm going to take 500 and I'm going to divide it by 1/2. You can divide by 0.5, but I'm dividing it by the fraction. And when I do that, I get 1,000, right? So if that's surprising for you, try dividing things by fractions and just kind of observe what happens on your calculator. So I get the number 1,000, and what that equals is b to the 3rd power. So in order to figure out what b is, I need to take the 3rd root, right? If I take the 3rd root of both sides, I'm looking at the cubed root of 1,000, that will tell me what b is, and then I could test it and make sure it works properly. Well, we have a way to do that with these calculators, and there's other ways to do it. If you have any scientific calculator, look it up in your manual, you'll figure out how to take different roots. On this calculator, I start by entering 3 because I want a 3rd root, and then I hit the math button, and I'm going to go down to option number 5, which is an xth root. And this calculator interprets this as the root that I'm getting is the value that's out in front. So this is going to be the 3rd root of, and then I'm just going to put 1,000 in parentheses. I don't think they're necessary, but when in doubt, I like to use parentheses. So this is roughly the 3rd root of 1,000. The classroom calculators actually display this much better. It actually looks like it's the 3rd root. Now, when I press enter, I get exactly the number 10, which is fabulous. So if x is 10, actually b is 10, I now know everything I need to know to write this equation. I'll go ahead and write here. So therefore b has to be the number 10. So I've got my answer. I know my 0th term is 10, and I know my multiplier is 1/2. So the equation I'm looking for is y equals 10. No, I'm starting at 1/2. I'm sorry. The 0th term is 1/2. Y equals 1/2 times 10 raised to the x power. So this is this function. Perhaps.